On December 19, 2025, something extraordinary passed silently through our cosmic neighborhood. No alarms sounded, no impact was expected, and yet, the scientific world hasn't been the same since. An interstellar object known as 3IATLAS, officially designated C2025N1, made its closest approach to Earth, then began accelerating away from the Sun in a way that defied everything we thought we knew about comets, asteroids, and interstellar debris. At first, it looked like just another wandering object from deep space. But within days, astronomers realized something was very wrong. It pulsed, it glowed rhythmically, it carried impossible chemistry, and most disturbingly, it appeared to push itself away from the Sun, using a force no natural comet should possess. Was this simply the strangest comet humanity has ever observed? Or was this something else entirely? Tonight, we explore the full mystery of 3IATLAS, the object that forced scientists to ask an uncomfortable question: are we truly alone? Or did something pass us by without stopping? Chapter 1. A Message from Beyond the Stars. The story of 3IATLAS begins like many modern astronomical discoveries. In mid-2025, NASA's ATLAS survey system, designed to detect near-Earth objects, identified a fast-moving body entering the inner solar system on a hyperbolic trajectory. That trajectory alone was remarkable. Unlike typical comets, which originate from the Kuiper Belt or Oort cloud, this object was moving far too fast to be gravitationally bound to our Sun. It wasn't from here. Astronomers quickly classified it as the third confirmed interstellar object ever detected, following the famous Oumuamua in 2017 and 2I Borisov in 2019. But from the very beginning, 3IATLAS behaved differently. Its path was precise, threading the inner solar system like a needle, close enough to be observed in detail, far enough to avoid danger. And then, on December 19th, it reached its closest point to Earth. That's when things became truly strange. Chapter 2. The Heartbeat in the Dark. As 3IATLAS passed perihelion, the closest point to the Sun, astronomers expected a familiar pattern. Comets heat up, ice sublimates, brightness rises, then steadily fades as they move away. But 3IATLAS didn't fade. Instead, its brightness began to pulse, not randomly, not chaotically, rhythmically. Telescopes recorded intense periodic fluctuations in luminosity, almost like a heartbeat. Bright, dim, bright again. Each pulse was stronger than the last. This behavior made no sense under standard comet physics. Natural outgassing is chaotic. Surface ice sublimates unevenly. Activity diminishes with distance from the Sun. Yet 3IATLAS did the opposite. Scientists proposed multiple explanations: a highly complex rotation, exposing active regions at regular intervals, explosive outgassing from deeply buried volatile pockets, or a layered internal structure never before seen in comets. But none of these models fully explained the consistency of the pulses. The signal was too clean, too regular, too intentional. And then came the chemistry. Chapter 3. Chemistry that shouldn't exist. Spectroscopy is astronomy's fingerprinting tool. By analyzing the light reflected and emitted by an object, scientists can identify its chemical composition. When data from 3IATLAS came in, researchers were stunned. Yes, there was carbon dioxide. Yes, there was methanol. But water, normally the dominant component of comets, was oddly scarce. Instead, the ratios were completely inverted. Even more baffling was what came next. Astronomers detected strong spectral signatures of nickel vapor. Nickel. In space, nickel almost always appears alongside iron. They are cosmically inseparable, born together in supernovae. Yet 3IATLAS showed nickel without iron. This pairing violation defies planetary formation models. To find nickel alone is like finding smoke without fire. Some researchers suggested exotic explanations. Fractionation during formation around an unusual star extreme age, causing selective erosion, or unknown chemical processes in interstellar space, but no known natural mechanism could explain such purity. And then, as if the universe wanted to push the mystery further, 3I. Atlas grew a tail, pointing the wrong way. Chapter 4. The Anti-Tail Paradox. Comets have tails for a simple reason. Solar radiation and solar wind push gas and dust away from the sun. Always, without exception, until 3IATLAS. Astronomers observed a narrow, highly focused jet of material pointing directly toward the sun. This wasn't a dust illusion. It wasn't a perspective trick. It was a real, stable structure stretching millions of kilometers. They called it an anti-tail. Anti-tails are extremely rare, and when they do appear, they are usually broad, diffuse, and short-lived. But this one was different. It was columnated, sharp, persistent, almost like a beam. Maintaining focus over such distances requires a level of control unseen in natural comets. Some scientists suggested electrostatic interactions with solar plasma magnetic channeling effects or unusual particle size distributions, yet simulations failed to replicate the observed stability. And then came the most troubling observation of all. Chapter 5. The object that refused to slow down. As 3IATLAS exited the inner solar system, something impossible happened. It accelerated, not due to gravity, not due to solar heating. It gained speed as it moved farther from the sun. This phenomenon, called non-gravitational acceleration, had been seen once before with Oumuamua, but 3IATLAS showed it more clearly, more powerfully, more persistently. The thrust appeared continuous, too strong for simple outgassing, too consistent for random venting. This meant one thing: there was an internal energy source, something was pushing it, and that's when one voice in the scientific community spoke up, again. Chapter 6. Avi Loeb and the Uncomfortable Hypothesis. Harvard astrophysicist Avi Loeb is no stranger to controversy. He was the first prominent scientist to seriously suggest that Oumuamua might be artificial. Now, with 3IATLAS, he went further. Loeb argued that no single anomaly proves artificiality, but the combination does. A heartbeat-like light curve, nickel-rich, iron-poor composition, a focused anti-tail persistent acceleration, and a precise interstellar trajectory. Together, he said, these resemble technosignatures. Loeb proposed several possibilities: a derelict extraterrestrial probe, a fragment of a light sail, or a piece of ancient interstellar technology long abandoned. The heartbeat could be a tumbling reflective surface. The nickel could be a manufactured alloy. The anti-tail could be a leaking thruster. The acceleration could be residual propulsion. Even the trajectory itself raised eyebrows. 3IATLAS passed through the solar system in a way that maximized observational exposure, almost as if it wanted to be seen. But extraordinary claims demand extraordinary evidence, and mainstream science wasn't convinced. Chapter 7. The Voice of Caution. NASA and the broader astronomical community urged restraint. They reminded the public of a simple truth: nature is often stranger than imagination. Their explanation? 3IE. Atlas is likely an extremely ancient interstellar comet, a relic from a star system utterly unlike our own. Its chemistry could reflect unknown planetary formation pathways. Its behavior could reveal physics we don't yet understand. Its anomalies could expose gaps in our models, not alien engineering. They emphasize that spectroscopy alone cannot prove artificiality, and so far no direct evidence of communication, control systems, or structured materials had been observed. To them, 3IATLAS wasn't a visitor. It was a lesson. Chapter 8. Life, Defense, and Human Reaction. Beyond science, the object ignited something deeper. Its cargo of complex organic molecules reignited the panspermia theory, the idea that life's building blocks travel between stars. If comets like this are common, life itself may be widespread. Governments also took notice. The event triggered the largest planetary defense tracking exercise in history, because while 3IATLAS posed no threat, the next one might. Public reaction exploded. Hashtags trended. Myths resurfaced. Political leaders joked nervously. Blue Kachina spread across social media. For many, it wasn't fear. It was wonder. Chapter 9. Too Fast to Chase. By the time humanity fully understood what 3IATLAS was doing, it was already gone. Moving too fast for interception, too distant for probes like Project Lyra or ESA's Comet Interceptor. We missed our chance, but not forever. New observatories, like the Vera C. Rubin Observatory, will soon scan the sky with unprecedented sensitivity. Interstellar visitors may no longer be rare. They may be routine. The question it left behind. 3IATLAS has left the solar system. It didn't attack, it didn't communicate, it didn't stop, but it changed us. It reminded us that the galaxy is not empty, that space is not quiet, that we are not isolated observers in a static universe. Whether it was a bizarre natural object or a silent relic of another intelligence, one truth remains. Something passed through our home, and we were barely ready. Next time, we may not just observe, we may have to answer.